Good morning, everybody. Welcome to the next video. In this video, I am going to explain the famous Nernst equation, its derivations, its temperature dependence, and the Nernst equation for Daniell cell, etc. Let us move to that. Nernst equation is a famous equation which is derived by the very well-renowned scientist Mr. Nernst, and he always preferred to find the variation of the factors which affect the cell potential. After a tremendous or a long years of research, he find that the concentration of the electrolyte in electrochemical cell and the temperature had an inevitable importance in the E cell value or the cell potential value. And finally, he reached in an equation that is known as Nernst equation. So, by definition, we can see that it is a or Nernst equation is the relationship between electrode potential and the concentration of electrolytic solution. First of all, he derived this Nernst equation or the expression for single electrode potential, and that equation is mainly considered as Nernst equation. Let us first of all we can move to the derivation part. Before deriving the equation, just keep it in your mind the Nernst equational format, because you know the equation from your +1 +2 classes. The equation can be written like this: E cell is equal to E0 cell minus 2.303 RT, the all divided by NF, that is all divided by only for minus 2.303 RT log, and we can call it as concentration of product divided by concentration of reactant. Okay, so in this derivation, I am going to derive this Nernst equation for a single electrode reaction. For a single electrode reaction, I am considering the equation as concentration of, Mn plus n electron give Ms. That is the general equation. I call this equation as equation number A. Then we need a framework of this equation. For that, I consider the Van Hoff reaction isotherm. Why? Because the Van Hoff reaction isotherm is a relationship between delta G and equilibrium constant K. This is for the reversible reaction, because most of the electrodes are considered as an electrode that is as reversible electrode. So according to this reaction, we can call the equation as delta G is equal to delta G0 plus RT ln K. That is this equation is known as Van Hoff reaction isotherm. When you insert an equation in a derivation, you have to explain the terms of that equation. So let us explain the terms. Delta G is equal to Gibbs free energy change. Delta G0 is equal to standard Gibbs free energy change. R is a universal gas constant, and T temperature is and K is the equilibrium constant. So just consider this equation. So we can see that E cell, instead of that G, delta G0 E0. So there is a small framework can be seen. Next, I consider this is we know the famous equation, that is delta G is equal to minus NF E cell. What's the meaning of this cell? The meaning is that how much the delta G is converted, how much free energy is decreases, that is the amount of electrical energy produced. Or by the statement, it is clear that in a reversible reaction, the electrical energy is produced at the expense of free energy decreases. How much free energy decreases, that much electrical energy is produced. That is the real meaning of delta G is equal to minus NF E cell. You got why we consider this equation, because we have to replace the delta G from this equation, and so this, and we have to replace this because these two terms are to be required. So delta G value, and so delta G0 value can be written as minus NF E cell. So we can put these values in the equation number 1. We get or sorry, just തിരുമ്പ് ഞാൻ പറഞ്ഞിരുന്നു, when you repeat or insert an equation, you have to explain the terms, where delta G is equal to Gibbs free energy, delta G0 is equal to standard Gibbs free energy, and E is equal to electrode potential, E0 is equal to standard electrode potential, F is equal to Faraday's constant, and N is equal to number of electrons transferred. So by inserting these values in the above equation, we get minus NF is equal to NF E cell is equal to minus NF E0 cell plus RT K, and I call that equation as equation number 2. Then from the general electrode reaction, which means that first of all we consider an equation that is M N plus N electron gives M. Okay, from this equation state that there is K. Here we can see that there is a term of K. Just replace this K by from this equation we got K is equal to concentration of M by concentration of Mn plus. Because why we write like this? Because the value of K is equal to concentration of product by concentration of reactant. So concentration of product, that is equal to M divided by concentration of Mn plus and concentration of N electron. We can say that we didn't consider this value of electron because it's constant value. So can be written like this. So substituting the value of K in the above equation number 2, we got minus NF E cell here as a subscript. Every subscript that is cell is be there. So a minus NF E cell is equal to minus NF E0 cell plus RT Ln, the concentration of M by concentration of Mn plus. Why? We replace the K in equation number 2 by concentration of M by concentration of Mn plus. You got it? So we know the general equation, but we didn't require, but the format of the general Nernst equation is E cell is equal to E0 cell minus 2.303 RT by NF log concentration of product by concentration of reactant. This part is okay, and this RT is okay. 2.303 will be obtained by converting Ln to logarithmic value. Then NF should be needed on the bottom, and here only E0 is be required, E cell is required. So we can substitute that the values just so you get the ideas clear. Since the concentration of M is equal to 1, the equation become minus NF E is equal to, E means E cell is equal to NS NF E0 cell plus RT Ln 1 by concentration of Mn plus. Just substitute the values, and by dividing, just that I am saying that we need only N E cell here, and my E0 cell here we need NF. That is, we dividing by equation, the equation by minus NF, we get E cell is equal to E0 cell plus E cell is equal to E0 cell minus, that is plus by minus, that is RT by LF log that is Ln 1 by concentration of Mn plus. Okay, that is, just revert the logarithmic term, so the sign gets interchanged. That is, E cell is equal to E0 cell is equal to E0 cell plus RT NF Ln concentration of Mn plus. So here the term is Ln, and we have to replace these values with its own values. That is, the value of concentration of R is equal to 8.314, T is equal to 2.998, F is equal to 96500. The value become E cell is equal to E0 cell plus 0.0591. That is the obtained by substituting by that is 2. For converting Ln to log, we have to multiply by a factor 2.303. So 2.303 RT by EF value can be written like this, 0.0591 in standard conditions. So the equation becomes this: E cell is equal to E0 cell plus 0.0591 by N log concentration of Mn plus. That is it. So, and that is the first Nernst equation for a Nernst equation for a single electrode reaction. I'm going to derive the Nernst equation for Daniell cell. So, Daniell cell equation is Zn plus Cu2 plus gives Cu plus Zn2 plus. Just do one thing. Just replace the term by K. So, general format is Nernst equation is E cell is equal to E0 cell minus 2.303 RT by NF log K or Q. Just replace the value of K. From this, K can be written like this: concentration of Zn 2 plus the whole divided by concentration of Cu2 plus. Here there is a concentration of Cu here, but here the concentration of Zn, but this value get cancelled because the concentration of Cu and concentration of Zn can be considered as 1 by convention. So K can be written like this: concentration of Zn2 plus by concentration of Cu2 plus. The equation become like this: E cell is equal to E0 cell minus 2.303 RT by NF log concentration of Zn2 plus by concentration of Cu2 plus. That is the equation for Daniell cell. Okay, and in my previous on the first of all, I on the initial time of this class I explained that rather than the concentration, temperature is having an inevitable importance on the value of E cell. So let us check what is the temperature dependence of E cell potential. Temperature dependence of cell potential, variation of EMF with the temperature. Just for that I am considering the Nernst equation for Daniell cell. We already know that E cell is equal to E0 cell minus 2.303 RT by NF log concentration of Zn2 plus by concentration of C2 plus. I am considering three cases. The case number one is concentration of Zn2 plus is equal to concentration of Cu2 plus. Just look at these terms. Concentration of Zn2 plus and concentration of Cu2 plus is equal to same. So what will be happen? This value, which means the value Zn2 plus Cu2 plus become 1. Okay, this value become 1. What is the value of log 1? Log 1 is equal to 0. If log 1 is equal to 0, minus 2.303 RT by NF term become 0. So what will be happen? We get E cell is equal to E0 cell. That is, the logarithmic term become 0, which means minus logarithmic term means minus 2.303 RT by NF log term, that is log Zn2 plus by concentration of Cu2 plus. That term becomes 0. That is, E cell is equal to E0 cell at that situation. Let us consider the case number 2. Here the concentration of Zn2 plus is greater than Cu2 plus. We can say that Zn2 plus is a higher value and a value of CO2 plus is a lower value. We can say that this value or this term should be greater than 1. That is the value x which is greater than 1. So we can say that if the value if the concentration of Zn is get more, concentration of Cu get minus, the value get increased and the logarithmic value become decreases. So we can see that first of all this when be the concentration of this cases get extended, so the value get reduced from this value, which means ഓരോ ഈ വാല്യൂസ് ഇവിടെ കൂടുന്നു എന്തുമാത്രം കൂടുന്തോറും അത്രയും ടേമിന്റെ വാല്യൂ ഇവിടെ കൂടും, which means the value of this get increased and that value get minus from E0 value, which means E cell value get increases with increase in temperature in this situation. ഈ സിറ്റുവേഷനിൽ വീണ്ടും ടെമ്പറേച്ചർ ഇൻക്രീസ് ചെയ്ത് എന്ത് പറ്റും? ഇത്രയും ടേമിന്റെ വാല്യൂ ഇൻക്രീസ് ചെയ്യും. സോ ആ വാല്യൂ എന്ത് ചെയ്യും? E0 എന്ന് കുറയും. സോ E cell വാല്യൂ എന്ത് ചെയ്യും? വീണ്ടും കുറയും. ദാറ്റ് ഈസ് ഞാൻ ഇവിടെ എക്സ്പ്ലെയിൻ ചെയ്തിരിക്കുന്നത്. ലോഗരിതമിക് ടേം ബിക്കം നെഗറ്റീവ്, വിച്ച് മീൻസ് ഇത്രയും ടേം എന്ത് ചെയ്യും? ഓൾറെഡി നെഗറ്റീവ് ആയിട്ട് മാറും, കാരണം ബിക്കോസ് ഓൾറെഡി ഇത് നെഗറ്റീവ് ഉണ്ട്. സോ E cell വാല്യൂ എന്ന് പറയുന്നത് E0 വാല്യൂവിനേക്കാളും ചെറുതായിരിക്കും, ബിക്കോസ് E0 വാല്യൂയിൽ നിന്ന് ഈ വാല്യൂ കുറയ്ക്കുകയാണ്. ദാറ്റ് ഈസ് ഇറ്റ്. That case, the reverted case, that is Zn2 plus Cu2 plus വരും. അപ്പോൾ എന്ത് പറ്റും? ഈ വാല്യൂ എന്ന് പറയുന്നത് ദാറ്റ് ഈസ് ഇറ്റ്സ് ലെസ് ദാൻ 0 വരും. അപ്പോൾ ഇവിടുത്തെ ഇത്രയും ടേം എന്ന് പറയുന്നത് നെഗറ്റീവ് ആവും, ലോഗ് ടേം നെഗറ്റീവ് ആവും. സോ ദ വാല്യൂ ഹിയർ ഇറ്റ് ഈസ് പോസിറ്റീവ്. സോ എന്ത് പറ്റും? ഈ E cell വാല്യൂ എന്ന് പറയുന്നത് കൂടും, when you increase the temperature. That is, the logarithmic term become positive if E cell value is greater than E0 value. EMF of cell increases with rise in temperature. That's about today's class.